We will give a presentation about blocking antibody. Blocking antibodies prevent a ligand and a receptor from meeting. The antibody binds to the receptor first, so the ligand can no longer access its binding site. As a result, the signaling pathway stays off. These are blocking antibodies. A blocking antibody binds to its target. However, it does not activate the receptor. In other words, binding does not create any downstream signal. Finally, I will introduce example where the function of blocking antibodies is actually used. Let's begin with anti-PD-1 and PD-L1. First, please look at the figure on the left. T cell attack cancer cell. However, when PD-1 binds to PD-L1, the T cell becomes inhibited and stops attacking the tumor.
A blocking antibody binds to PD-1 or PD-L1. This prevents that interaction and removes the inhibitory signal. As a result, T cells regain their activity and attack tumor cells. The discovery of the PD-1 pathway by Dr. Tusk Honjo led to the development of this therapy and was recognized with the Nobel Prize in Physiology or Medicine in 2018. Next, I'll introduce anti-IL-6 receptor therapy. IL-6 is a key inflammatory cytokine. It binds to the IL-6 receptor and GP130, forming an active signaling complex. Anti-IL-6 receptor antibodies bind to the IL-6 receptor and prevent IL-6 from binding. As a result, the signaling complex cannot form. Clinically, these antibodies are used to treat diseases driven by excessive IL-6 activity. By blocking IL-6 signaling, they reduce inflammation and improve immune regulation.